Hello everyone, this is Mrs. Broderick and we're going to go through the notes 7.1. So we're going to start talking about circles. So first off, circle is the set of all points in a plane equidistant from a fixed point called the center of the circle. So if I were to draw a circle here, we have the center of the circle, and then circles are always named by their center. So we can call this circle O, or we can actually use a circle symbol and write it that way. All right, concentric circles, two or more different circles that share the same center. Okay, so an example of concentric circles would look something like this. Oh, mine's off a little bit. Let me move it. Oh no. Okay, that was a little tougher than I thought, but I got a nice diagram here now. So concentric circles would look like this, right? Two circles that share the same center. So they're almost like they're overlapping, or one circle is going to be within the other. And then we also have congruent circles, which are circles that are going to be the same size. So they would have congruent radii. So let's see how good I can get these two circles. Yeah, close, right? So if we had this circle here, let's just call it circle A and say its radius was a length of 3. And we had another circle, say circle B, and also had a radius of 3. Okay? So let's divide these up to go with those 3 different examples. Okay, so now let's get into some of the different features of a circle. So if we have a circle, a radius is a line segment with one endpoint at the center of the circle and the other endpoint on the circle. So let's still use circle O. Say this was point A. We would say that OA is a radius. Okay, a chord, a segment whose endpoints are on the circle. Okay, so the endpoints are on the circle. So let's say something like this. So that would be, our example would be BC. And then a diameter is a chord that passes through the center. So the endpoints are on the circle, but it must pass through the center. So that's called DE, our diameter. Okay, so use the diagram below to answer questions 1 through 14. So name the center of the smaller circle. Okay, well, if I look at the smaller circle, the inner circle there, its very center is here at A. Now, A is also the center of the large circle. Okay, so since both the smaller and larger circles share the same center, what word from above best describes the circles? When they share the same center, they're called concentric circles. Okay, name a radius of the smaller circle. So that means it has to be coming from the center A and touching the edge of our circle. So something like AC would be an example, right? We could also use AD or even AB. So notice I'm not extending outside of that small circle. Okay, name a radius of the larger circle. Okay, so now it has to be coming from the center A, but it has to touch our exterior circle. So that would have to be A all the way to I. Okay, name a point in the interior region of the smaller circle. So now we want something that's actually inside of the circle. Okay, so something on that inner part. So if I look inside the circle, well, F, B, E, D, C, those are all on the circle. So A would be our only point that is on the interior region. Okay, the exterior region of both circles. Okay, so completely outside of both circles would be H. And then a point that's in the the exterior region of the small circle, but on the interior of the large circle. So again, we're looking for this little strip here. So that would be G. Okay, and I'm going to erase this stuff because I got a lot going on right now. All right, name a chord, right? So we name a chord, endpoints have to be on the circle. So our only chord in this diagram would be EF, not our only chord. BC would also be a chord. So I guess we can include BC. You can do either one. But more specifically, BC would be considered the diameter because it passes through the center of the circle. All right, what is the diameter of the smaller circle? Okay, well, we're not given a diameter, but we are given a radius. So we know AD is 8, which makes then, all of our other radii 8. So if I want the diameter of the smaller circle, it ends up being 2 of the radii, which would make it 16. Okay, so that's something kind of important to add here, right? The diameter is equal to 2 times the radius. So if we want the length of the larger circle, or the diameter of the larger circle, well, a radii, AI of the larger circle is 8 plus 3, right? This whole thing would be 11. So its diameter would be 2 times 11, or 22. Okay, area. So notice this little box here gives us our area formula. So area is r squared times pi. So what is the area of the large circle? Okay, well, we know that our radius of the large circle is 11. So we have 11 squared times pi, which would give us 121 pi. Now we're going to leave our answers in terms of pi, which means that we're going to have pi in our answer. So it is an area, so let's put units squared on there. The circumference of the smaller circle, well, for circumference, we can either do 2r pi, or we can do pi times d, or d times pi, either way. Since we know the diameter of the smaller circle from number 11 is 16, well, d times pi would be 16 pi. And again, I'm just going to put a little u there for units. All right, so that's it for day 1. Nice quick notes for you guys. Have a good day.